Alright, what we want to look at in this video is we want to talk about acceleration. And so, you can think of acceleration as being the rate at which you change your velocity or speed. So let's take a look at this. If you're on the road and you're driving along on the road and you're in your trusty car, in this case it's always a truck that can draw squares, and you're in your truck and you're driving along and you have some speed here. You're going, let's say, 25 miles an hour, and then a little bit later, at some point later, you're now doing, let's say, 50 miles an hour. Well, the way that we actually measure your speed change, how quickly you changed your speed, is we do that through acceleration. And so the acceleration is essentially you take your velocity. Let's say we call this your speed 2, your speed at position 2, your speed at location 1, speed 1, speed 2. Well, it's the differences in your speed 2 minus speed 1, over time 2 minus time 1. So just like when we talked about velocity and speed being the change in your position, acceleration is the change in your speeds in some given time. And so acceleration measures the rate at which your speed changes. And of course, when you want to buy expensive sports cars, this is what you're paying for, right? Your 0 to 60 time. How fast can I go from 0 to 60? Well, you're paying for how fast, the smallest amount of time possible to go from 0 to 60. You're paying for acceleration when you pay for fancy, expensive sports cars. So the idea is that acceleration is the rate at which you change speeds. So if you change your speed in a short period of time, you have a large acceleration. Now, what you can notice is your acceleration can be positive or negative, because speed 2 could be smaller than speed 1. So let's say you go from 25 miles an hour to 0 miles per hour. You slowed down, right? Because your acceleration is negative. Your car went from some 25 down to 0. 0 minus 25 is some negative value. This is like braking. So braking is a negative acceleration. Now, this is we can use speed in here instead of velocity, because you can use speed in place of velocity whenever direction isn't important. And so speed can be used in place of velocity whenever direction is constant. But really, acceleration isn't speed changing. Acceleration is a velocity. So really what we should put in here is velocity 2 minus velocity 1. And you change velocities in time, then you have an acceleration. Because you could not only change your speed, but you could have some direction change. And in order to change the direction, you need some type of acceleration as well. So acceleration is the rate at which you change your velocity or speed if you're direction is constant. Now, one other thing to think about is you can also think about using your velocity. Your acceleration changes your velocity. So you can also think about acceleration being a change in your, changing your velocity. So how can we think about this? Well, we can think about how Galileo was thinking about it. So Galileo would start with the ball at the top of an inclined plane. And then he would measure the speed. He would measure the speed of his ball at some point. So we have like time equals 0 here. Some amount of time, this is time equals, time 2 down here. Well, the speed here at the top, or speed or velocity at the top, let's say is 0. Well, your velocity down here is some value. Equals some, equals some velocity here. And what you can think about is your new velocity here at the bottom, your velocity then is equal to the acceleration you experience times the time you applied that acceleration for. So essentially, your velocity is equal to the acceleration times the amount of time 1 minus time 2, and that would be your new velocity. So you could also think of your velocity as being the acceleration times your time that you apply it for. Now, whenever we have, let's say, time 2 minus time 1, time 2 minus time 1, we can also call this delta t. So anytime we have some type of change, so time 2 minus time 1, this is like a change in time. And one thing we do in physics, one thing we use is we use this symbol called delta, this little triangle, and it stands for a change in, or a change of. So delta t is a change in time. And essentially what happens is, instead of having to write time 2 minus time 1, we would write delta t. So really, your velocity is equal to your acceleration times some amount of change in time, delta t, which is now off screen. So acceleration is equal to velocity is equal to acceleration, your A, acceleration, times your delta t. And so the idea is that you apply your acceleration for some amount of time and you get your new velocity. And that's essentially what happened when Galileo was rolling his ball down the hill. So remember, acceleration is the rate at which you change your velocity or speed. Or if you're thinking about, well, I want to know what my new speed is, your acceleration times your time, because accelerations are necessary for changes in velocity, accelerations times time give you some new velocity. So that's what we have. Acceleration is a rate change of your velocity or speed, and we can also think of velocity being equal to our acceleration times our